Hey, welcome back to the tin can lectures. This is a can of crushed, peeled tomatoes that was sitting in my pantry. And so, like, I can set my phone up here. It's kind of DIY, but, we do what we can. So we want to look at 6.5 and 6.6 practice sheet in the same module. This is week 2, I believe. We're still factoring, but the reason why these two are together is because 6.5 kind of puts all of our factoring techniques together in one section, but it doesn't tell you which technique to use when they give you a problem. So like number 1, when you have 27y cubed minus 9y squared plus 12y, I don't know if I'm supposed to use GCF or grouping or the trinomial diamond method or the snowflake method or the PST, perfect square trinomial, or difference of squares or cubes. We have 7 different factor techniques and I don't know which one to use. So I go to my 6.5 notes and I see that, oh, no matter what, I'm always checking for the GCF. And look, for these 3 terms, 1, 2, 3, they all have a 3 in common. And they all have a y in common. And that is my GCF, 3y. And then when I divide by 3y in each one, I get what's in this parentheses. So 27 divided by 3 is 9. Y cubed divided by y is y squared. 9 divided by 3 is 3. And then we get y. 12 divided by 3 is 4. And the y's cancel. So there we go. Okay, I got a squeaky chair. So I would love if this was just done, but I don't know if it's done because I got to figure out if this factors. Now there's a couple of things I could try to get it to factor, one of which I'm looking at it and I'm going, oh, this is 3 terms and look, perfect squares. But if I were to look at the square root, which is this is 3y and this is 2, and I multiply them together, that would be 6y, and that is not half of the middle. So this isn't a perfect square trinomial. That's not going to work. So then I go, okay, well, what are my other options? It's 3 terms, and there's a number in front, so I would try snowflake. Okay? It might not work. I don't know. -3 is the middle term, then 9 times 4 is 36, I believe. Starting to lose my ability to multiply. Oh, gosh. Quarantine. Anyway, so now I'm looking for 2 numbers that multiply to give me 36, but add to give me 3. Well, that's not going to happen. Like the 2 lowest numbers I can try is 6 and 6, but they had to give me 12. So this isn't going to work. So he doesn't factor. I just had to check. I didn't know. Only GCF works for this problem. And I'm going to check the answer because I'm not super confident, but there we go. That's what it says. This is the answer. All right, let's try another one. 10x squared plus 6x minus 15x minus 9. You have some options. So right away I'm looking at this and I go, what about the GCF, huh? Always look for the GCF first. Well, 3 goes in all 3 of them, but not him. They don't all have x. So it doesn't look like there is a GCF for all 4 terms. Wait a minute. 4 terms. That is grouping, isn't it? Now, if you don't like factor by grouping, you don't have to do it. You know why? Because those 2 terms can be combined to create a trinomial. But I like grouping. I don't know why. I like grouping. What? So just the left side, looking for the GCF, we get 2x. And then I'm going to divide by 2x from both, and I get 5x plus 3. The x's cancel. Over here, the GCF looks like 3, but negative 3. So I'm going to divide by -3 in both of them, and I'm going to get positive 5x and positive 3. Hey, those parentheses match. That's awesome. So I'm going to write that parentheses 1 time. This is factor by grouping business. And then I'm going to put these oddballs, these 2x and the -3 together. I don't want to call them oddballs, whatever. And there's your answer. Now you could have gotten the same answer by combining these and doing snowflake if you wanted. All right, number 3. we have x squared minus x minus 72. So right away I go, okay, there's no GCF. I just have to check every time. And then I go, how many terms do I got? I got 3 terms. So this is a trinomial thing. And this isn't a perfect square, so I'm not going to do that business. But I can go off to the side and do this little x method. -1, the middle number, goes up here. -72 goes down here. And then I go, what 2 numbers multiply to give me 72 and subtract to give me 1, or -1? And it's -9 and +8. So this factors into x minus 9 and x plus 8. Done. Nice. So like all of these is just throwing back to all of the techniques, the sections that we've covered in this chapter, and just making you go, okay, look at it, and then figure out what to do from there. The first thing is always check for GCF, and then the number of terms should tell you what to do. So like here, the number of terms was 4, that told me grouping. Here, the number of terms was 3, that told me X or snowflake if there was a number in front. Here, there's 3 terms, but I'm not there yet. I got to do GCF first. So GCF, they all have a 5 in common, right? So let's do 5. And let's divide each one of these by 5. And I'm left with x squared minus 4x plus 4. Now I see 3 terms, and I could go, oh, okay, this is the x thing again. But I also notice, hey, these are perfect squares. So if this was the square root is x, and the square root is 2, and if I multiply those 2 together, that is half the middle. So I just bring down the minus, wrap it up, put a square on it, bring down the 5, and I'll be all done with that problem. Now, if you wanted to do the x, you'd find -2 and -2, and you'd be right, x minus 2, x minus 2. That's correct as well. No worries. Number 5, we have x to the 4th minus 7x to the 3rd minus 8x squared. GCF says x squared is the GCF. And if you divide each one of these by x squared, I'll be left with x squared, and then 7x, and then 8. Okay? Now what I'm left with is a trinomial, and they're not perfect squares on the end, so I'm going to do the old x method over here. -7 up here, -8 down here, and then I say, what 2 numbers multiply to give me 8, subtract to give me -7. -8, +1. Yeah? That works. So this becomes x minus 8 and x plus 1. Don't forget your x squared in front. Okay? So we're just factoring. We're getting good at it. We're trying all our different techniques out, getting some practice. Number 6, we got 2x squared minus 11x plus 12. And the first thing I look for is, yep, that's right, the GCF. But there isn't one. The 2 doesn't go into 11, and there's not an x in all of them. So moving on, no GCF. We got 3 terms. They're not perfect squares on the end, so since there's a number in front, I'm going to do the snowflake. If you don't do the snowflake, like if you do trial and error or factor by grouping method is also another way of doing these trinomials, go ahead. It's perfectly fine. I like this, so since you can't talk to me during these videos, I'm going to assume that you like it too. So -11 goes in the top, and then 2 times 12 goes in the bottom, right? First times last, always for snowflake. And then I stop and I go, what 2 numbers multiply to give me 24 and add to give me -11? And that is -8 and -3, right? 2 negatives make a positive, and those 2 add. Okay, and what number goes above them? It's the first number, 2. Now I want to reduce any of these side fractions. So this becomes 1 over -4. I'm going to circle it. And 2 over -3 is already reduced. Okay? So those are the numbers that are in my answers. It's always blank x blank, blank x blank. So in this case, it's 1x minus 4. And then it's 2x minus 3. All done. Okay. A little practice doing the snowflake for you. 16x squared plus 16xt plus 3t squared. And yeah, notice I curled my t because the plus looks very similar. It confuses me. So with this one, I'm looking at it, first of all, GCF. Let's see. No, 3 doesn't go into 16. And this guy doesn't have an x, and this guy doesn't have a t, so there is no GCF. So then I go, okay, 3 terms. This is a perfect square, but this isn't. So the perfect square trinomial won't work. And so that leaves the snowflake. Again, more practice with the snowflake. Middle number goes up here. 16 times 3 is 48, I believe. And then I go, what two numbers multiply to give me 48 and add to give me 16? 12 and 4. There you go. 12 times 4 give you 48, and then 12 plus 4 is 16. Then I put that first number, 16, above both of them, and then I reduce. This, they both have a 4 in common, so when I divide, I get 4 over 1, circle. This, I know, it doesn't matter the order. This, they both have a 4 in common, so when I divide by 4, I get 4 over 3, circle. So that means that my answers are going to be 4x plus 3, 4x plus 1. So this number and this number have a letter that goes with it because we started off with 2 letters like this. So the first number always goes with the first letter, and the second number always goes with the second letter, if that helps. There you go. Number 8, we have 18x squared minus 63x minus 36. All right. GCF, maybe there's a number that they all have in common. Let's find out. Let's see. 9? So I start with the smallest number when I do GCF, if they're bigger. I start with the smallest number. I go, wait, does 18 work? Is 63 divide by 18? Let me pull out my calculator. 63 divided by 18 equals. Nope, it's a decimal. That's no good. So then I go to the next highest factor of 18, 9. Does 9 work? Yeah, it's 9 times 7, isn't it? Is it? Wait. 9 times 7. Yeah, it is. Okay. And then that's 9 times 4. I feel more confident about that. So they all have a 9 in common. That means I need to divide a 9 out of every one of them. So we get 2x squared. We get 7x. And we get 4. Yay. So I would love to be done, but I'm not. There's 3 terms. There's a number in front. They're not perfect squares, so snowflake again. -7 goes up here, and 2 times -4 goes down here. So then I go, what two numbers multiply to give me 8 and subtract to give me -7? That's -8, +1. The first number inside the parentheses, 9 is no longer involved, goes on top, like so. Now I reduce, divide by 2, and you get 1 over -4, circle. 2 over -1, I'm sorry, 2 over +1, doesn't reduce. We don't want whole numbers for snowflake. And then, all right, so that means that this guy becomes 1x minus 4 and 2x plus 1. And then don't forget your 9 out front, and you'll be all done. Numero 9. We have 64x squared plus 80xy. Oh my gosh. Plus 25y squared. So these numbers are a little juicy, but one thing that I noticed right away, first of all, GCF. GCF, let's see, okay. Okay, so for the smallest one is 25. 25 doesn't go into those two. And then the next highest factor of 25 is 5. Only 5. So, yes, no. All right. No GCF. Moving on. I got 3 terms. I could do the snowflake, but if I did that, I would have 80 in the top and then 64 times 25 on the bottom. That's a big number. I don't want to do that. But wait a minute. Before you give up, look at them in terms. The first and last term, they're perfect squares. If I break them down, I get 8x and 5y. Huh. Now, if I multiply them, I get 40xy, and that's half the middle, isn't it? Woo! So I'm going to bring down that plus. I'm going to wrap them up, and I'm going to put a little bow on it, and I'm going to be done with that problem. See? Sometimes these little techniques help us go much faster than other techniques. Like snowflake would have been awful. Let's do another one right there. We have number 10, 50x squared plus 40xy plus 8y squared. All right. And again, this looks very similar over here. First of all, GCF though. Oh, they do have all some. So look, start with 8 and go 8 goes into him. It doesn't go into him. So then we go to the next highest factor, which is 4. 4 goes into him, doesn't go into him. So then we go to the next highest factor, which is 2. 2, 2, and 2. Yes, they're all even, so 2 works as a GCF. They don't all have the same letters, so only 2 is the GCF. That leaves me with 25x squared, 20xy, and 4y squared. Now, if I hadn't done this 2 GCF first, I would have been doing snowflake. And first of all, I would have gotten it wrong, because if you do snowflake before the GCF, you're going to get it wrong. I don't know if you know that. Now you do. But not only that, you're going to get really big numbers, and it's going to be a little daunting. Here, you would also get very big numbers, but before I do that, look here, there are perfect squares on the ends. Maybe this works. 25x squared becomes 5x. 4y squared becomes 2y. Multiply them together, get 10xy, and that's half of the middle. So I bring down the plus, and I wrap it up, and I put a little square on it, bring down the 2. There you go. Okay, number 11. We have a 36 minus w squared. It's much smaller than all of his previous guys. And sometimes that happens. You get a smaller problem after a bunch of big problems to kind of help you catch your breath. And in this case, I have 2 squares with a minus sign in front of it. So if you saw the video for the 6.4, you would know that this guy breaks down into 6 times 6. This guy breaks down into w times w, and then we put a plus and a minus, and we're all done. And order matters, so make sure 6 is first. There was nothing else to that. That was nice. I immediately saw there was no GCF, but maybe you didn't. Maybe it's good to just have that thought process where you go, is there a GCF? Well, they don't both have numbers, and they both don't have letters, so no. But, you know. This is cubes. Now, 343 you might not know is a cube, but I'm looking at cubes because of that guy. I'm like, wait a minute, I bet that guy's a cube. So I pull out my calculator, and I go 343, and I hit that cube root button, and ooh, it's a 7. So when I break this down into 2 and 3 terms, like so, that's what you do with cubes. This guy becomes just t, and this guy becomes 7. That's the cube root of 343. Now, these 3 are found by these 2. This guy times himself, this guy times this guy, and then this guy times himself. And again, if that's confusing, go back to the other video and look at it again. And then use SOAP. Bring down the plus, same, opposite, always positive. All done. And remember, that trinomial never factors when we do cubes. It's good to know because now I'm not sitting here going, does it factor? I don't know. Let's try some numbers. No? I don't know. Maybe. All right, so let's talk about equations. Equations are just like all of the problems we just did, which is why I put them together, 6.5 and 6.6. But for equations, there's an extra step. So with equations, you factor, and then you split them up. Split them up and solve each. So that's kind of what we're going for when we deal with equations. This is a very short version of the notes from 6.6. Well, let's look at x squared minus x equal to 20. Now, I can't factor until everybody's on one side, like a quadratic equation. So what I got to do is I got to get everything to one side. So that means I'm going to have to subtract 20 to both sides. Get this. Okay? Now I'm going to factor this trinomial. Now this trinomial factors by using the little x method, if you want. -1 is the middle number and -20 is the last number. Don't worry about equal to 0, right? It's just this trinomial that I'm factoring right now. The equal to 0 part will come back later. So I've got this set up and I'm going, okay, what numbers multiply to give me 20 but subtract to give me -1? That's -5 and +4. So I'm going to write x minus 5, x plus 4 as my factors equal to 0. So factor, check. Now I'm going to split them up. X minus 5 is equal to 0, and x plus 4 is equal to 0. Check. Now the reason why I'm splitting them up is because it's 0. It's equal to 0. This is the only number that you get to do this with. So if I had done factoring x squared minus x equal to 20, and I found the way this factors, and I set them both equal to 20, that'd be wrong. No, 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 no. Only 0 works for the split them up step. And then I solve. So all I have to do is add 5, and I get x equal to 5. All I have to do is minus 4, and I get x is equal to -4. Done. Okay, let's try another one. 2x squared minus 16x plus 30 equal to 0. So here everything is already on one side. Yay! So I can look at what all that is and go, hey, is there a GCF? Sure is. Look, 2 is the smallest number, but he goes into everybody. They don't all have an x. So 2, and then when I divide by 2, divide by 2, divide by 2, divide by 2, I get x squared minus 8x plus 15. Now, still working in the factoring because this is a trinomial inside the parentheses, and I can work that out. Lost some room. Here we go. Up here. -8, 15. That's the middle and the last number inside. And so then I go, what two numbers multiply to give me 15 and add to give me -8? That's -5 and -3. So I would write x minus 5, x minus 3. And don't forget your 2. Now, it's not that big of a deal in equations if you don't have 2 here. And we'll look at that in just a second. So we're done with factoring. Now we're going to split them all up. 2 equal to 0. X minus 5 equal to 0. And x minus 3 equal to 0. So 2 equal to 0 gives me nothing. There's nothing. So this number can't be equal to this number. So this doesn't make any sense. It's like gobbledygook. It's I don't care. This guy though gives me x equal to +5, and this guy gives me x equal to +3 because I'm adding 5 and I'm adding 3, right? Boom. So I have two answers. This 2 didn't do anything to find my answers. He's just kind of redundant. You know that word means? It means you don't need it. Last problem on this practice sheet. We got 16x squared equal to 36. Remember, it's got to be equal to 0, so let's subtract 36 to both sides. And we get 16x squared minus 36 equal to 0. Now this is important, and it might be against what you feel like doing. What you might feel like doing is dividing both sides by 16 and then taking the square root. That is something from your past, and we haven't talked about it a whole lot. We're gonna do that more in college algebra, but right now we're just gonna factor. We're gonna move everything to one side and factor. So here we have 2 squares with a minus sign, so I get to factor it using difference of squares. Square root is 4x, 4x, square root 6 and 6, one's plus and one's minus. That's factored. Now we split them up. 4x plus 6 equal to 0, and 4x minus 6 equal to 0. I ran out of room. So let's go up here. Now 4x minus 6, we're going to subtract 6 from both, and we're going to be left with 4x equal to negative 6. And then when we divide by 4, we'll have to reduce to get negative 3 halves. Divide by 2 in both top and bottom. So that's one of my answers. The other one, I have to add 6 to both sides, so I get 4x equal to positive 6. And then when I divide by 4, I'm going to reduce again, and I'm going to be left with positive 3 halves. So my answer was negative 3 halves and positive 3 halves. Okay. All right. There you go. There's just 3 equations that are on there. That means that there won't be a whole lot on that quiz. In case you haven't looked at it yet, you need to. Okay. See ya.